It sounds like we both went to SIGGRAPH in 1996, and that's where we both sort of got our first experiences with VR, saw all the activity that was happening both in industry and academia. And, I remember when we did meet, just saying like, it was that moment where I was like, people get paid to do this. How fun, how amazing, want to be part of it. Right. And that's, I think for both of us, what led our journey ultimately to UNC, to University of North Carolina to study it better. I think my recollection is we met when you were visiting and interviewing. I
Mm.
think you came out
Yeah.
to visit before you joined, and we went to dinner together. I think you were at Hughes at the time, Hughes
Yeah,
Research.
Hughes Research Lab. No, actually, now that
Yeah.
I think about it, yeah, 2001. So 1996, I'm getting those two dates confused. So I was at that conference in SIGGRAPH 1996 in New Orleans, and I saw Dr. Brooks give a presentation. I saw Mark Monet give a presentation, and just doing these amazing things. And I was blown away. I was like, this is what I want to do with my life. And ever since. And, I also just realized that, ironically, that was the first time I had worked on a VR project was in 1996. That same summer as the conference was working on an immersive medical visualization project. So it's interesting how this comes back around because we'll be talking about medical applications today. But yeah,
Yeah,
2000
very cool.
was at Hughes Research Laboratories, and I made this crazy decision to go to graduate school. I kind of wanted to, instead of being, you know, I wanted to make decisions, right? And if you have more of an advanced degree, it's easier to sort of make those decisions versus being told what to do and be able to follow your passions. And so I bailed from one of the most awesome jobs in the world. Then soon after that, the market tanked and everyone was laid off at my work. So I was very fortunate of that timing serendipitously working out. And so Sharif is one of the first people I met as one of the students kind of showing me around of, if you're going to go to graduate school, this is going to be what you're looking at, and some just awesome people and awesome projects. And after that, I said, hell yeah, let's do it.
I'm glad I got to be part of the crew that recruited you. Yeah, I mean, for me, it wasn't as strategic as you. I wasn't thinking of long-term career. I got interested in VR, exposed to it when I was working at Lockheed Martin and in Silicon Valley, and realized where is the best place to learn how to do this? Where is the place where they have the equipment and like-minded people that I could work with? And so for me, it became clear, well, all the action is happening at the time in grad school. And so one of the amazing things about UNC was, not just the funding that was very specific towards visualization, graphics, and VR, but also it was a place where all of the people were, there was a critical mass of people who were really passionate about this and really good at it that I could learn from. I think one of the things also that was special about UNC was at some universities, some research labs, every professor, every primary investigator, they have their own lab. They have their own equipment that they bought with their own grant money. It's very hard for a grad student to, for example, use equipment that does not belong to their professor. And at UNC, what they did is, this was under Fred Brooks's leadership and, Henry Fuchs and the rest of the professors there, is they pooled all their equipment. So there was one common graphics lab. Professors' offices were on the periphery, but in the middle was one shared lab, and graduate students from any professor were welcome to use whatever the equipment they wanted to in the middle of the night. In fact, Russ Taylor told me a story about, he had a really expensive force feedback device, the Phantom, and it broke in the middle of the night. So somebody might have been playing with it, but it broke in the middle of the night. And his instinct was, well, this is really expensive. I'm going to repair it because I need it for my research, but maybe I'll keep it in my office now and students can check it out when they need it. And then he thought, no, that's actually defeating the purpose. Like, it needs to be out there where a grad student feels free to be able to use it without asking permission. And if it breaks, it was worth it because some student got exposed to it in the right way that they could have used it if they wanted to, or just play with it. And if it gets broken, that's money well spent. They'll fix it and put it back and keep doing it because that's the value it brings to the community. I thought that was something really special about where we went to school.
Another thing about that is not just collaborating at projects at the time, but forming those relationships, right? That bonding of being in the same physical space where,
Mm-hmm.
now I may go be at a conference and see someone I haven't, talked to in 20 years, but we're in the same lab versus hidden away in offices. And so, yeah, just that that network that you gain from that solid network, not just, I happen to go to school with this guy, but
Oh yeah.
we
And a
spent
lot of
nights
us,
in the lab.
we're there at 2 a.m. and, students and professors from different research projects are still helping each other debug code at 2 a.m. Right.
Yep.
And so I think another outcome of that was a lot of students had their own dissertation ideas, and sometimes they switched advisors in order to pursue those ideas.
Yeah.
I certainly did.
I did as well.
And that was encouraged. Right. But it wouldn't have happened if we didn't get to see what other research projects were doing and have access to their equipment in the middle of the night.
Yeah.
So it was
I
it was
think
a very
another
fertile
good
ground
lesson,
for invention and discovery.
another good lesson is how Dr. Brooks put that together as far as focusing on a niche, right? Similar to business. If you try to make everyone happy, often you make nobody happy, but really
Hmm.
focusing on more specifics. And the reason why that department was able to do so well, even though UNC does not have an engineering school, right? It's crazy that, they focus on computer science, virtual reality being that top school, even though there was no engineering, but because of that niche he focused on.
Yeah, if I'm remembering correctly, and so if anyone in the audience knows differently, but my recollection is he chose Carolina because it didn't have an engineering school. Because computer science was normally computers were happening in the electrical engineering department, and he realized from IBM that thinking about computer science algorithms was a different kind of skill than worrying about voltage and power and the
Mhm.
normal things you make to build a computer. In order to understand how to program a computer and understand about the mathematics and the algorithms, it's a very different focus. And so there's something to be gained by actually having computer science isolated from engineering. But then on the other hand, how does a school like UNC that doesn't have an engineering program compete for grant funding and talent with Harvard and MIT and the other big schools? And I think that's why he focused on visualization, graphics, and VR as a niche, because that specifically wasn't respectable at the other computer science schools. That by and by that way, the department would attract a critical mass of people to be able to move that forward.
And also looking at specifically, computer graphics and, interactive techniques and such, there's so many crazy things that came out of that department, right? Whether, work on the haptics, whether it's 6DoF tracking that's used pretty much, those same concepts that are used in so many tracking systems nowadays, or, the GPU and just all these crazy things that came out of that department because they were able to niche. Then eventually that niche like became these grandiose things that are common
Mm.
throughout the world nowadays. It's insane.
Right. Yeah. So like, Mark Harris in our cohort came up with the term GPU. His dissertation was on using a graphics processor for initially cloud rendering and then generalizing it to other sorts of things that you wouldn't traditionally use a graphics card for. And then, of course, Henry Fuchs, who had the radical idea that you could have a programmable processor per pixel, which, of course, led to pixel planes and pixel fusion, pixel flow, and then ultimately what we call the GPU today.
Or
Yeah, it
what
was a
we
really
call
exciting
AI
time.
today, right? That general purpose programming.
Or
It's
enable, yeah, right.
insane.
Then and that led to floating point in the GPU, which led to CUDA, which then made it possible to do the large AI models that we have today.
Yeah.
You should have folks from should have Henry and Mark
Oh,
and several
absolutely.
other folks on the podcast to talk about
Yeah,
that
yeah. We
history.
need to add them to the list for sure. Now, specifically for you, your very specific niche that sort of expanded out, especially in the research community of redirected walking. I'd love to hear like your story, how you got to redirected walking, although maybe back up for listeners that don't know what redirected walking is, sort of give that high level overview of what that means.
Yeah, sure. So, uh, very simply, redirected walking is fooling somebody to walk in a circle when they think they're walking in a straight line. And you might ask, well, why the heck would you want to do something so stupid? And the reason is at UNC, again, our UNC heritage, we had one of the only tracking technologies where it was big enough to be able to walk several meters, right? So typically at the time, we might have used electromagnetic tracking, and so you could move your head like this, and you could look around, but you couldn't walk from one corner of a kitchen to another. And UNC, in collaboration with Mel Slater at UCL in London at the time, discovered that it's really important to walk and to really walk, not teleport or use a joystick. because by really walking, you have a greater sense of presence. People behave and feel more like they're in the real place. And for some applications, like maybe phobia desensitization or having a client of an architect understand what the building's going to feel like when they build it, being able to feel like you're there is really important. And so you want to be able to really walk. At UNC, we also had a model that was of Fred Brooks's kitchen, right? So he was trying to remodel the kitchen for his house. It's a very challenging problem. These 3D models of the kitchen that were designed or built by generations of grad students, like going in with rulers and cameras and measuring the kitchen and looking at the blueprints. Under that tracking ceiling with the headset that we had, you could walk around a good portion of the kitchen, and people were just stunned at how realistic it felt. And I was disappointed because I was like, well, I don't want to see just the kitchen. I can see that there's a dining room over there with a view of a tree, and I want to go there and see what that's like. Or can I see the kitchen from the dining room? And we couldn't do that at the time because we had the largest tracking system in the world, but couldn't, even that one was only big enough for a kitchen, not for a whole house. So, my motivation was I want to be able to really walk and get to the whole house and not have to fly with a joystick or teleport. And how could we do it? So if you can fool the body's balance system into making you turn without making you realize that you turned and without making you extra motion sick, then it's a win. So that was the crazy idea that I got to by being at a place like UNC and having collaborators at the HIT lab in Seattle, where Tom Furness and Don Parker, one of my PhD advisors, was there, and then Anthony Steed and Mel Slater in London. It was just an amazing time and place.
Yeah, you had an amazing team in place. Legends
Yeah,
like
I was
that.
very lucky.
Yeah. Yeah. And I'm curious, you could have had a very successful career continuing with that. I mean, you could, become a professor there and that becoming your specialty, but you instead went into the medical space. So what was sort of the decision-making process there?
Yeah, I mean, I was really lucky. I had an offer to go somewhere else and pursue redirected walking full time, which in some ways is the dream. But at that point, I had been doing demos and grants and papers for probably 10 years at that point. And after some soul searching, realized I'm an engineer, not a scientist. And you might say, well, how are they different? Like we often talk about science and engineering and STEM in the same word, right? And scientists and engineers both build things, right? But a scientist, they build things to learn about the universe or to learn about the world. So the goal is learning. And engineers, of course, do plenty of learning and might do research, but in the end, our goal is to build something that's useful to somebody else, right? Which is also, fits in with Brooks's notion of the toolsmith, right? So as computer scientists, we build tools for other people, and that's how we should be judged, by how useful they are to our users. And so I realized, I think redirected walking at that time, there was only a couple of places in the world where you could do it. And those systems still were at least hundreds of thousands of dollars, if not millions of dollars. When we were in grad school, we got to use the 7-rack SGI that was called Evans, which, if I remember correctly, was a $4 million computer at the time. And then a tracking ceiling, which was only one of in the world, with millions of dollars of grant funding to build that thing and make it work. And so there wasn't really I couldn't think of something where it would immediately help a user or help a user quickly, right? So like writing a paper about redirected walking can inspire lots of other people, and it's a lot of fun. We can learn more about the balance system and how perception works. But I was itching to help a user who didn't care about the technology and provide some benefit for them. And so that's where I realized I want to pivot to building something that would go out commercially, a production product that could help something. And of course, in the graphics lab, we had a couple of professors who were also working and had strong collaborations with the university, the hospital, and the med school at UNC. And so, in Henry Fuchs's group, they had been doing medical augmented reality for a while, and in Henry Fuchs had I've heard from Henry Fuchs I heard from Fred Brooks that Henry had the observation, I didn't hear it directly from Henry, that since the 1980s, medical procedures are getting less and less invasive. So, for example, we can, instead of cutting a patient open, making a large incision and doing direct surgery where the surgeon can put their hands on the organs and see them with their own eyes, we can insert small cameras through keyhole incisions. We can use ultrasound. We can use CT imaging. In the heart, we can insert catheters that go through the neck or the groin to get into the heart and work from the inside, work from the outside in. And so all of this is good, but the more less invasive the medical procedure gets, the more 2D monitors that the doctor has to look at. So instead of seeing the organs in 3D with their own eyes and being able to touch them with their own hands, they're now looking at a 2D monitor or several 2D monitors. They might be looking at X-ray, at ultrasound, at a camera view, and there's more opportunity for getting spatially disoriented or for missing something. And so Henry's idea, as I understand it, was to be able to address this using augmented reality. Can we make it back like it was when it was open surgery without being open surgery? And so so they had done a couple of studies with all that expensive equipment, for example, showing that for something like breast biopsy, it's a tacit skill. So what I mean by that is how well the physician does has nothing to do with like maybe what kind of grades they got in med school, but simply the number of times they've done that procedure before. And so somebody who's been doing it for 20 years is going to do much better than somebody who's been doing it for 2. It's a difficult thing to teach. And so what the AR system that they had come up with at UNC had done is shown that everyone can get better, become more accurate, require fewer sticks to do it with an AR headset than just using 2D ultrasound alone. And that even the world experts got better, but novices got even better. And so I thought, well, maybe that is an opportunity for commercialization. Other folks in the lab had spun off to form InnerOptic from that lab. And so I thought, that would be a really interesting place to try to figure this out with them.
Yeah.
Yeah.
And so you were, go
Sorry,
ahead.
go on. No, you go ahead.
So you were at InnerOptic. You were their CTO for several years, I believe, right?
Yeah. So I was there for 10 years. That's how long it took us for the journey of going from research to finding a commercially appropriate product and finding product market fit.
Yeah.
Right. So, you look at where it started. So at UNC, it was for breast biopsy and it was for laparoscopic surgery. Those were 2 examples that InnerOptic was interested in. At the time, that system was probably a couple $1 million. Again, it used the 7-rack SGI that was $4 million by itself and some very exotic tracking equipment.
And
so
custom built AR headsets, right?
Oh yes, right, yeah, and our own AR headset. And so I'm guessing it was maybe a couple $1 million of equipment, and we showed that clinically it does result in improvements. But it was for a medical procedure that maybe the doctor earned $50 doing a breast biopsy, right? And so not a good business solution. Spend a couple $1 million to help you with a procedure that makes $30. And to be clear, that wasn't the point of the UNC research, right? Like, it's like saying, oh, I invented a time machine, but it's too expensive. You're like, well, the fact that you could even make that thing work was the massive generational achievement. And so, it took us that long to figure out, well, is there something that maybe the hospital or physician makes more money doing on the business side, but also on the clinical side is still really difficult and would benefit from using AR technology? And what is that application? And so that search and that sort of iteration and trying lots of things, doing that with studies, talking to lots of customers, that ultimately took 10 years to get to 2 products that now are out there being used every day on patients, which I'm very proud of.
Yeah, that's interesting. A customer discovery at a university is so different than in a startup business situation. Because at UNC, you were definitely doing customer discovery, right? Of working with other professors and hospitals and such of, how might this work? But it wasn't like with a goal of getting that return. So yeah, I guess very different.
Yeah, I mean, the goal of the university is to help the world and the country get a longer term return,
Right.
right? So you do the foundational science and the things that no one else can afford to do. And by doing it, it ultimately leads to things like the GPU and to, 3D graphics that
Yeah.
now you can, get in $100 machine,
Yeah. Or the
right? But
tracking
it
and
doesn't,
all the
right.
custom built headsets and all of that.
Yeah. And
Yeah.
it doesn't produce that it produces a different ROI for the university. And at the university, the goal is to educate and to do this groundbreaking research and to produce people that can go out into the world and do good things. Again, Brooks used to say people are our product.
Yeah. Yeah. I remember that.
So it's a different kind of ROI.
Yeah. So what were those specific use cases that you looked at InnerOptic?
Yeah. So ultimately, there were two. The first one was for uterine fibroids. So uterine fibroids are benign masses that can happen in the uterus. And the very surprising thing to me, I was surprised about this, and I was surprised that I didn't know it, was that it impacts a third of American women at some point in their life, right? And it causes all sorts of symptoms such as severe pain, bleeding, etc. It can prevent fertility or impede fertility. And in the US, a sixth of American women will ultimately have their uterus removed because of it, a hysterectomy, right? So it's the leading reason to have a hysterectomy. And so that's a very severe treatment, removing the entire uterus because of this problem.
Yeah.
And so our collaborators, an OBGYN surgeon, came up with a therapy whereby inserting a special kind of needle through the skin in a minimally invasive surgical procedure, you could insert it through the skin, get the tip of the needle into the fibroid, and then deliver radio frequency energy into that fibroid and thus treat it that way. And it'll shrink the fibroid without damaging the uterus, without having to remove the uterus. And also the patient, fewer side effects. They could return to work a day or two later. So a really ingenious technology. And they had done clinical studies on, I believe, several hundred patients at the time. So they were showing really good results. But the problem that the business folks realized in this company was that there were only like less than a handful, I think two or three OB surgeons that had that enough experience with it that if they were in the room, other surgeons, if they were in the room proctoring, other surgeons weren't comfortable doing this procedure on their patients,
What do you mean
right?
by that?
So, well, it's a difficult procedure to learn, or it was a difficult procedure to do. And so if you're a surgeon who's never done this before, and it's a very difficult procedure, you want the person who invented it in the room with you, looking
Mhm.
over your shoulder, guiding you. That's called
Right.
proctoring in,
Okay.
in the surgical space. Sorry, I'm using some jargon now, and I didn't even realize it. But thank you for asking. Yeah, so that's called proctoring. And so, if your goal is to be able to help a third of American women, you are not going to get there if there's only two or three doctors who have to be in the room for that to happen.
Yeah.
And so, from a business point of view, you got to find a way that is more scalable, right? So it's easier to learn, maybe faster to learn, and maybe somebody who has less expertise than the world expert can do it competently and safely. And so that was what led to our collaboration with them. And so they asked the question, could we apply some of our technology that we had been developing at InnerOptic for their procedure in order to make that procedure easier to learn, easier to train, and then easier to perform. Allow people with less experience to get the same phenomenal results that the most experienced physicians were getting.
And so were you able to do that?
Yeah, so that was a great collaboration in the beginning. Their goal again was novices. So for a while, we would have a new version of the software, like a new prototype of the software, the user interface. They would have a revised version of the hardware, and then once a week they would test it with some physicians. We would get notes that night, and then start another week-long sprint where we would iterate that again. And within a couple months, we got very close to what ultimately ended up being our final commercial solution. At this point, they've now sold high three digits of those devices. And I have friends that have been treated with it. And so it's actually, I'd say one of the highlights of my career was for this device. Typically in the early days, if somebody used it, somebody from InnerOptic would be in the room during that procedure to witness it firsthand and be able to talk to the users, understand what was difficult, what was easier, where could we improve it. And so we had now gotten to a point where surgeons were using it without us being there. And that itself was unusual. Like that was remarkable to me that like, oh wow, now people are using it and I'm not there. I
That's the
kind of
threshold of
right? Like
something
that's
being
kind of
successful.
crazy. And then one of these surgeons one of the early surgeons who had used it without us being there was so excited about it that he like reached out through the clinical representative to get our contact info and reached out to say thank you. And what he said is like, this procedure used to take me hours. It was difficult. And then the first time I tried your version of the machine, um, I did it in less than half an hour. And I think I spent 10 minutes just exploring this machine because it was the first time I used it. So to be able to take somebody that had done it the old way and it took them hours, and then the first time they try it, with the new version, they could do it in 30 minutes and thought maybe next time they'll do it in 20 minutes. That was hugely rewarding. So to me, that was the
Yeah.
definition of success. And now the fact that it sold, close to 4 digits number, and it's been used on friends and other people I know is yeah, extremely rewarding. That was the reason why we started down this path.
Yeah, that's amazing. I mean, that's the most rewarding. You can make a lot of money or something, but when someone comes up and say you change things for the better, for my life and my patients, that's
Yeah,
amazing.
right.
Yeah.
So still chasing that dream. I've got to have that experience,
Yeah. We get hooked and we want that. That's our, some
right?
people get it from Instagram. They get that little dopamine hit. We get it from
Right.
helping
This is
people.
a huge dopamine hit. It takes 10 years to get it sometimes.
Yeah. And my understanding is you've also done some work for liver cancer as well. Is that correct?
Yeah. So, yeah. So for liver cancer, there's a pre-existing therapy, which is also ablation. So again, you're putting a needle this instead of into your fibroid, putting it into a liver tumor. And it's one of the ways you can treat liver cancer. Other ways include chemo, surgical removal of a tumor, that's called resection. The medical societies that produce guidelines that say what therapies are effective for what kinds of cancers and for what kinds of patients, right? So those are called the guidelines. There is a subset of cancer patients, a pretty large subset, for whom ablation the ablation treatment would result in the best outcomes. That means they live longest, it's less invasive, so there are fewer side effects, right? And in the US, it also, from a business point of view, happens to be well reimbursed, which means the surgeon and the hospital can get paid for performing this service for their patients. And so at Medtronic, which was our collaborator on this, our partner, their internal data showed that despite there being so many patients for whom this should be the best therapy, only 10 to 20% of them were actually getting it. Right. So what's happening to the rest of them? The rest are getting something that was less effective and maybe had worse side effects. So open surgery, radiation, things that were more invasive, and ablation. Also, this therapy is particularly good early in the cancer when the tumors are small. But for 34% of those patients who have this early stage cancer, they're actually receiving treatments that are more appropriate for late stage cancers, which have a lot more side effects, right? So the question that Medtronic was facing is why? Why is it so underutilized? And the answer that we came up with is that because the procedure is difficult. And so one physician published a paper and found that it took 50 procedures to the point where a doctor would get consistently good outcomes with ablation, right? 50. So if you're a new physician that is now offering this, finished a fellowship and is going to a place where patients couldn't access this before, um, 50 procedures might take 5 years to get to. Well, who is going to keep referring patients to you if you're not getting consistently good outcomes or you're getting inconsistent outcomes for 5 years, right? So like 50 is a lot. If you have to do 50 before you can get consistently good results, that means it's a very difficult procedure.
Yeah, that's one thing with first responders is what we hear is you focus on those high risk, low frequency events because it can get
Mm-hmm.
like decades to get the experience you need because they're so rare. So you can, it's easy to train for the things that happen every day. You don't need that training. You're doing it every day.
Exactly
But
right.
the rare things, yeah, is where really need that.
Yeah. Another one that we studied at InnerOptic, we looked into was like for internal bleeding. So you can imagine if like somebody fell off the roof, they might be bleeding internally. And, uh, you know, if they're in a rural area, that might result in, well, they need to get on a helicopter to get to a level 5 trauma center where they
Yeah.
can treat this before it gets too bad. But that helicopter ride is really expensive, right? And so you really want to be able to figure out who can go home and walk it off and
Yeah.
who needs to get on a helicopter, right? And
Okay. The
so
triage.
there is an ultrasound exam called the FAST exam. I forgot what it stands for, but using ultrasound, you can check for internal bleeding. But it
Yeah.
turns out that in order to, and now there are small, cheap ultrasound machines that EMTs can carry in their pocket. But it turns out to be able to recognize this internal bleeding from that ultrasound exam, you have to have seen it a couple times before. And you only get that experience at a level 5 trauma center where they have this happening a lot. So if you're a rural EMT, a rural physician, the ultrasound machine may not help you if you've never been able to see a positive FAST exam before. So exactly to your point, right? It's those rare things that's hard to train for.
Yeah, normally a lot of tools and technologies you sort of are first used by the subject matter experts, the world leading, experts in that space, right? But with these technologies, I mean, you want to work with those people to figure it out. But actually, I could see where your early customers aren't necessarily that because you build that intelligence and that training to those people that haven't been involved for 50 years.
Yes. Yeah, that is the opportunity I think that we're looking at, right? So again, with liver ablation, if only 10 to 20% of the patients who need it or would benefit from it are getting it, right? What's interesting there is there are already world experts who are very good at this procedure and have great outcomes, and they are busy treating
Yeah.
patients, but they can't, there are not enough of them to treat all the patients who would benefit from this, right? Just like if you had a handful of OBGYN surgeons who are the world's experts, that's not enough of them to be able to treat the third of American women that might need this procedure.
Yeah.
So very, very similar parallel there. Um, and so with the device for Medtronic, we used real time 6-off tracking. We used 3D rendering from the point of view of the surgeon. All of this to sort of reduce the learning curve. So, um, I think for me, one of the biggest signs of success was that, well, one, the first couple physicians who bought it or hospitals who bought it uh, weren't um, weren't the traditional podium speakers
Mm.
that we would expect to see at an academic liver conference, right? So typically, the way, as you were mentioning, a lot of new technology is rolled out by first going to the world's experts, and then they use it, they talk about it, they help actually to refine it and develop it. Certainly for us, we did too, by working with the world's experts. And then they give talks about it and they publish papers about it. They start teaching their own fellows this technique, and it spread slowly to the rest of the community.
But with these newer technologies, if you take that intelligence and you take that knowledge and you can build it into a system, something that you can visualize, then you can get to those less experienced users more quickly.
Yeah. So I think the opportunity here with XR and the related technologies is that we can scale these complicated procedures and we can democratize them, right? Make them more accessible to more physicians. And
Yeah.
so with the Medtronic device, the the thing that was surprising to a lot of folks inside of Medtronic marketing was the first customers weren't the traditional, we call them KOLs, key opinion leaders. These are the experts who are usually at academic hospitals. They're giving talks from the podium at these academic conferences. They're writing papers. And that's traditionally who you'd be the first ones to buy a new gizmo, a new device, and be able to do research on it, help improve it. And then when it's ready, teach it to fellows, proctor other options, and be able to have it eventually take root. But what's unusual is our XR inspired navigation system with Medtronic. The first folks who bought it were not those traditional KOLs who were speaking at the academic conferences. They were in areas that weren't able to offer this ablation therapy to their patients before. And that was really encouraging, right? So
Yeah.
the value, the return on investment for those hospitals was actually much higher than at the traditional academic KOL hospitals, because those expert physicians are already doing this procedure all day.
Yeah.
By buying an expensive machine, they're not going to be able to treat a single more patient than they could before.
Yeah.
They might
Or
treat
maybe
them
it's a
better,
small
but they're not going to treat
incremental
more.
change.
Right. It's an incremental change for them. But
Yeah.
for a place that didn't offer this service before, because it
A
was
game changer.
took too long, or it didn't happen enough, and if they and it's democratized for them, the fact that they can offer this to their patients now means there's going to be a huge amount more reimbursement they can collect. So they're not only helping a lot of patients that will benefit from that help, but they're actually making a lot more money for their hospital by doing this. And so the
Well, that's
ROI
a
for
pretty
them
rare
is bigger.
find. So yeah, it's sort of for me, the ideal use case of these technologies is what can you do with these technologies that are impossible to do with traditional ways, right?
Right.
Traditional
Or
approach.
difficult to do.
And so, even if you're getting a 50% improvement, that's minor compared to doing something that's just not possible. And so that's one of the challenges we found is how do you compare that? Because the baseline is like nothing, right? And so,
Yeah.
yeah,
Yeah.
it's game changers.
Infinity is hard to do
Yeah.
the math with, right?
Now,
But
with
yeah,
that
so
being
like,
said, they're hard to find those use cases. Just applying, these technologies to anything because you can. I don't think that's really the right approach. But really
no, but
understanding
like,
pain
but in
points
this
is
case,
difficult to do.
for the device from Medtronic, one of the early users, he, and I'll quote, said, uh, laparoscopic ablation is a 5-hour exercise in frustration. And then the first time he used our device, that was his, introduction to it. He bought one, and then first time using it, at he for the second day of use scheduled 4 patients that day. Right. So if the procedure takes 5 hours, you're not going to do more than one.
Yeah.
But he was so confident and got such good results after just using it once that the next day he was confident in getting 4 patients in that day. And so like the value both for those patients and for the hospital was huge.
Yeah, so that's not just the underlying technology. That is a great result of good UX, right? So a lot of
Yes.
times UX is just like, oh, it was a nicer experience, but no, that's a obvious effect there.
Yeah. Right. I mean, it made the procedure more accessible. I think that's
Absolutely.
the ROI for everyone involved.
So what do you think? To some sort of start summarizing here, what do you think the takeaways are when you're looking at new projects or looking at new use cases? Maybe, in the medical space, although answer it how you want, you could expand beyond that. But what are your thoughts of what the key takeaways are?
Yeah. So I think the one of the things XR and related technologies could be or is really good at, right, is 3D. We have millions of years of evolution to be able to understand in 3D when we're looking at it with our 2 eyes, with head motion parallax and within arm's reach, right? And so a lot of difficult tasks are difficult because of nuanced, complex spatial 3D relationships.
Yeah.
Right? That's true in a lot of medical procedures. It's also true in a lot of other procedures, perhaps maintenance or where you don't have the access that you like to do. So even in an industrial setting, if you're working through a camera rather than working on something with direct hands, because it's inside of maybe a nuclear reactor or in an awkward position or it's too big or too small. But XR is particularly good at conveying and helping people understand things in 3D and manipulate them in 3D. Right.
Yeah.
So I think that's a very fertile ground for this kind of work. So that's the first takeaway. I think another takeaway is we're going for impact. Right. So we're not doing that just because. I mean, it is fun, right? It is amazing, but the reason we're doing it is because we hope that there will be an impact, and commercially that means there's going to be a return on that investment.
Yeah.
Right. So understanding carefully who are we trying to make that impact for? What is that business? What are those users? Um, and then what is appropriate for them? Right. So what are the things that we could measure that shows if this is working or not? Not just if it's cool.
Absolutely.
I think another takeaway is avoid hype. So, right, a lot of people will want to use, I mean, the hype is very powerful. It makes it easier, for example, to get an investment to say, today it'd be I'm working on AI or I'm working on XR. But I think if we get very, very specific and say, who is the user we're helping and what is the quantitative benefit that we could do, and then think about how we might be able to improve that, that's how we get to real value,
Yeah.
right?
I suppose one way to think about it is looking for those use cases that have real consequences, whether that's, high risk or that's these dangerous situations or you do something wrong, bad things can happen. But on the other hand, you got to be very careful the way you implement these technologies and do them well and do them appropriately and not taking on too much risk. And so, what are your thoughts as sort of that risk analysis? What are the use cases of where to apply these technologies? Where do you need to be more careful? What to be sort of targeting?
Yeah, that's a great question. I mean, I think one, you earlier pointed out a lot of things that we need to either train for or do, they happen infrequently, or they are new and there aren't people who have done enough people who have done them before, right? And that's an excellent use case for XR. Um, and technology, any procedure can be made better, but making it perfect isn't actually the bar, right? The bar is making it better or easier or more successful than it is today. We can do small stepwise increments, right? So if there is a way of training somebody to do a dangerous procedure and it doesn't result in the training, for example, that you'd like, when you look at the outcomes a year later, do they remember that training? That's a great opportunity. And it doesn't mean that you have to get 100% of your trainees, in this case, have a perfect score on the exam a year later. What is successful for an XR trainer, for example, would be that more people do more appropriate things a year later. Not that they got it perfect. Obviously, we'd love them to be perfect, but if we do better than we were doing before, then we have another opportunity to improve it yet again in the future. And we shouldn't let that perfect be the enemy of good enough or better.
Yeah,
Jason, the other thing I wanted to bring up is the user and the customer. If we do it right, they won't care if it's an XR or not. That only matters to us. It doesn't matter to them. What's important to them is that we solve their problem. And so, in the case with InnerOptic and the two examples I talked about, or two products, we started by building our own headset and selling it to other universities. But in the end, our product doesn't have a headset. It has a 2D discrete. And we found that by rendering cleverly from the surgeon's point of view, we guess we were about able to give about 80% of the benefits to the user of having a headset without a headset, right? It's still arranged. We're still using a lot of XR related technologies. We do a lot to make sure it's very low latency. We're using 6-off electromagnetic tracking. We're using very nuanced 3D rendering. And all of that, from a user's point of view, they're not thinking about this being AR at all.
yeah,
They're thinking about this is a way to help them treat their patients for uterine fibroids or for liver cancer. And that's all that matters. So we need to make sure that we play in the space of the problem while we use our technologies rather than trying to play in the space of the technologies, right?
absolutely.
All of these, we're toolsmiths. That's to serve that end user.
Yeah,
Um, and then, the other thing is like a lot of problems that we face in both the enterprise realm, the industrial realm, the medical procedure space, as you and I have been talking about. A lot of those problems involve difficult spatial relationships, be it welding on the backside of something or doing a task that hasn't been done frequently. And if any of your listeners, if their users are having other challenging things that are difficult to train for or things that are difficult to perform, we would love to hear from you. We happy to help brainstorm, talk through potential ways XR and XR related technologies might be able to apply here, and to introduce you to other people that can also help find those solutions for you. So, this is what we do. It brings joy to our lives, is being able to talk about these problems and brainstorm solutions to them.
Absolutely. And yeah, exactly right. It doesn't have to be XR. Sometimes it's a good fit and sometimes it's not. Or maybe it's, some derivative with those similar concepts. And so, if you're out pitching or you have an idea for a product, right, start with what the issue is. What is the problem? What is the pain point you're starting to solve when you're talking to your customers? And yeah, they may not even know what virtual reality or augmented reality is, right? A true
Right. And they shouldn't have
solution,
to.
it should be transparent to them of the technology disappears and you transported to that solution, whether it's in an immersive space or if it's just magically happening through whatever technology it might be. The technology ideally is transparent.
Absolutely.
Okay, as Sharif said, reached out to Sharif or reach out to myself or heck, maybe both of us. We'd love to get on a call together. Sharif, I have known each other for a long time. So we love you brainstorming with people on these concepts. With that, I
Absolutely.
want to thank you, Sharif, for your time. As always, these conversations with you are always not only interesting, but extremely insightful and get me to think in new ways. And
Likewise.
so I highly suspect that that's the case for our audience as well. With that, we will see you on the next episode.
The Impactful Realities podcast requires more than a conversation. It takes action, research, and collective wisdom. If it made you think, we'd love to hear your insights in the comments or contact us directly to shape the future together. Don't just subscribe, pass the torch, put it forward, send it to the next one in your circle who manifests things that matter, the builder who dreams big and innovates towards more impactful realities.